Okay, so hopefully you can able to see my screen. So, uh, if you are a new resource over here, so just a few recap what we have covered till now. So we have started the new chapter for cloud computing. So 2 days has already been covered on that topic. So yesterday we have covered the EC2 and S3 bucket. A sample S3 bucket and sample EC2 instances spin up. From the snapshot, we have the examples on top of snapshot in AWS console, and just few more topics or few more components which are highly, required for your project purpose, especially if you are a big data employee or if you are willing to work in big data. So first of all, EMR is the main thing over here as we are talking in AWS. Maybe if you are working or willing to work in Azure, then you can go ahead with Databricks, this kind of stuffs, this kind of components that you own. But if any such aspects in future over there to cover the Azure part as well in our course, then surely you can cover that stuffs as well. Then we can quickly touch up what is Docker and all. What is the main functionality and what is the exact thing is Docker. Then some AWS serverless operation. After that, we'll be moving to Git. So Git is one of the code-based repository. So we can store whatever we have developed at our side. And it's also a version controlling repository, we can say. So today, after covering those earlier stuffs on AWS, few components, then we can quickly touch up Git, some basics in Git, to run the Git command from your command prompt line. Then if everything is completed, I think today Git basics I'll be covering, and tomorrow some more detailing part with Git we can quickly cover to end up this entire session. Okay, so let me get started over here. Whoever is not there, hopefully they will be checking the recording part and they should be having some idea. But if you have any doubt or any stuck point, you can quickly ask me. Okay, then. So cloud computing, as we have covered EC2 and S3, those are the highly available component, not highly available. Actually, I mean to say that all of the project, they're using those kind of, those two components because those are very famous as well. I mean, each of the project, they require this kind of stuffs. That's why. So in this course, actually, it's not possible for all the components to be covered. So that's why I have taken the main part. Main component which are useful and you should be having some idea on AWS console. That's why I have covered those two. Okay. So I'll be covering EMR. EMR is Elastic Map Reduce. So it's obviously cloud big data platform. So we can use, Hadoop, Hive, everything, related to Hadoop components is readily available in EMR, but we have the customized option as well. While spinning up an EMR, we have the customized option which kind of big data components I'll be pulling or installing. Okay, I should be having various options, just I have to choose it. Based on our project requirement or our project architect, they will be telling us we can choose those kind of stuffs. Maybe when we'll be going to spin up an EMR, we should be having those options. All the big data components should be in front of me, but I have to check on the checkbox which is required and which is not required. We should not check the box. Then we just have to fill up some more details, just like okay. So as this is a distributing file system, we'll be working on the distributed file system. So the things, all the data should be distributed in manner. So we need core node, master nodes as well. I think you are aware that core nodes, there are master node as well who are giving tasks to the task nodes. Task nodes are slaves. Okay. Master nodes are managing those slaves. So we are segregating or we are distributing the entire big file and we can split them to the task node. So that's why while spinning up the EMR, we just have to think what is the number of core nodes, maximum number of core nodes, maximum number of task nodes as well. Their memory allocation too we need to think about. So how much RAM, how much hard disks we need to give them while spinning up the entire EMR system. Okay, and EMR is actually highly scalable because in runtime as well. Suppose our job is running on top of an EMR. For a particular job, the file size is not big. So by default, hopefully I can have one master node or two task node there. So the job should be running segregating the file to two task node over there. But maybe if there is a millions of records of database we are fetching from any database, or maybe a big file we are processing, then these two task node will take much more time. That's why we have the scalability option in EMR, which we can control in the runtime of the job as well. And what we can achieve over there, we can increase the core numbers as well as task nodes number from there. So those all kind of configuration we can set up. We have to assign a set of VPC because as there are many computer in the EMR, many servers are associated. We need to choose some VPC. A subnet, a set of subnet, because each of the, when a particular thing or task node is running, then they will be taking one IP address over there and they will be running. So those are the all steps, basic steps for EMR, and it's generally used for big data purpose. The main core things is Hadoop. Okay, now quick introduction on top of Docker. Docker is very important tool. Docker, it's not, we can directly say it AWS component, but in AWS as well, we have Docker features. So it's a software development platform to deploy app. The main, properties of the Docker, I can design an app that, that particular, why it's Docker, why needs Docker. So we can package that particular app in a container so that the container can be triggered from any kind of OS. Maybe it's a Linux, maybe it's a Windows, maybe it's a Mac OS. So just like Docker has that capability, and it's working as the interface to run that particular app between multiple OS. Okay, uh, so you can scale containers up and down. Okay, in the next slide, we should be having a Docker hub actually, where we have to store the Docker images, and those are the image. Those images are one-to-one mapped with the container. The container I was talking about for Docker. Okay, maybe next session I'll be asking from the admin with some, practical setup for hands-on quick experience on top of Docker. I do not have a current, a tool or something to debug to show with you, but the basic thing, Docker works just like in this way. Okay. Now in AWS features, we can hear that AWS, some of the components are serverless in nature. Okay. So serverless means when we can directly take the application from the AWS. The cloud provider AWS, there is no such, we do not need any spinning up of EC2 server or S3 bucket or just like this. We can directly put our code. Maybe the code is in Python, maybe it's a JavaScript code that I need to mention earlier, which kind of code is there, or which particular code base. It should be supporting all kind of code base. The most important one, and we can directly run it without launching a server. So that is why it's called serverless. Okay, but at the actually the server is there at the backend, but actually we are not managing or we are not spinning up the server, and AWS is not calculating the money or pricing thing for this backend server. And we are just checking this kind of thing in top of just we are writing the query over there and we are triggering it. So this is, they are just, taking the computing power or the number of times we are executing, just like for AWS Lambda function. Okay. So we can put our code, we can put our Python code. We have to choose it's Python or maybe it's a JavaScript. So if we choose Python, we just have to write the Python code and we have to execute it. And for each execution, the price is imposed on top of that one. Okay. And I think execution time is also required. Maybe I'm processing a big code over there. So the processing of time is also required. So it's just like computational power price per second. So this is the way they're taking the money. And there is also some, I mean, various kind of databases, just like RDS, some messaging tool as well, some storage spaces as well. RD, I mean, for databases, RDS. Nowadays, we can also heard that Redshift as well. It's serverless. Earlier, we need to choose a server over there, but nowadays we do not have to choose. We are directly taking the applications which is readily available in AWS. It's working in a backend server, but we do not have to bother on top of that one. We just pay for this application. We just have to choose the application over there, and we can use. We can take the credentials. We can get it from AWS console itself. What is the credential of the database, and we can directly work on top of that. So there is AWS step function is also there, which can help us with serverless operation. Okay. So moving to the next topic. Yeah. So AWS till now, whatever we have covered, this is very high level one. I did not go ahead for more detail because it's a data engineering courses and the basic thing, whatever we have learned, I think that is sufficient for a data engineer. But if you are already working and if you have already accessing the AWS console, you can go ahead with various stuffs, various services as well, and you can, I mean, check what are the particular component is used for high level. But if it's in your project requirement, then that should be helpful for your hands-on purpose as well. Okay, but as of now, what we have will learn that is that will cover the basic stuffs. Okay, so the next topic is Git. Git is it's a totally new topic. Actually, I think you have already heard if you are an engineering background student and all. So Git is obviously a version control system. It's free and open source, and it's also distributed in nature. So multiple users can work distributed manner in Git. And Git, I mean, first of all, I mean, what is Git? Actually, we write some code, especially developer. We write maybe SQL query, maybe we are writing some Java code, maybe we are writing Python code, maybe that can be in different languages as well. Uh, so that particular thing to track, maybe we are pushing something in production. So in the next phase, we are editing the same stuffs and pushing the same thing in production. If there is any change required, suppose I need to roll back I mean, the earlier change again because there is some fault in the second go live, then we can roll back the thing from the first again. So Git will help us with that stuff because it's totally, I mean, we are version, whatever we are pushing into production or we are go living it, Git has the capability for versioning the stuffs. Whatever version or historical changes we have made can quickly face that thing. Okay. So yeah, so these are the main things I want to mention. Track changes. Okay, those are the features we can tell as well. So track changes across multiple files. Time travel to old version that I told that if we want to check if there is a faulty production movement, then we can check what is the old version. Then we can work accordingly. Roll back to the previous version that I already mentioned. Collaborate and share changes. If multiple developers are working in a single project, then we can share the changes. We have to push each of our changes to the main branch or main repository so that everything should be available. Otherwise, one developer has worked and he has committed his work and that moves to production. But one other developer they have worked, but I mean, they might have also commit their side's code, but that should not be going to production. This is a faulty one. That's why to remove this fault, we can collaborate and share change. We can combine the change. We can also compare two sets of version of a project. Okay. So those are all the features. Now we have also heard about what is, the GitHub, Git and GitHub. Those are two different things actually. So Git is specifically a software and GitHub is a service which worked on top of this Git software. So Git is a command line tool. GitHub is a GitHub is a graphical user interface only. And Git is also, it's installed locally over there, but GitHub, it's it's hosted in web. So in web, we can work in GitHub. Just like GitHub is same as GitLab. If some of you have worked in GitLab as and all of the stuffs, then you can find those are same. But Git is the main core thing which we need to install in our local system. So those are the all stuffs we can quickly just check it from here. There's some other differences as well. Okay, the last point I was mentioning, Git competes. Those are the other component or other competitor of Git. Those are also version controlling stuffs, just like CVS, Azure DevOps Server, Subversion, Mercurial, and GitHub. The competitor of GitHub is GitLab, Gitbucket. AWS, there is a component that is called AWS Code Commit. Okay. Okay. Now I'm moving to Git again. So if you want to install Git in your local system, then this is the website gitscm.com. I already have opened that one. I think, yeah. So just open that website gitscm.com and here is the software. You can directly download and install it at your system. After installation of that thing, you can find from your Windows that this is the particular software called Git Bash. So we can type the command line thing over there on top of Git Bash. Okay, so that thing should be working in this way. Let me show you few of the command line code as well. Okay, first of all, those are the Git GUI. Some GUI is also there, which is whatever we are writing over there in code in Git Bash. The same thing can be done with some Git GUI. So the most popular Git GUIs are GitHub Desktop, Source Tree, Tower, Git Kraken, and Git. So those are the important one. Now one important aspect. So if you are going to work in a particular company, is the company is it's a big company over there, then the Git repository creation and all kind of stuff you do not have to maintain by your own. If you are working as a data engineer, developer, or support, okay, so there may be separate team for that one. So suppose for your work purpose, for your project purpose, for your particular application that you are supporting, you need a particular repository, so they can create the repository by their own. Okay, so they will be creating the repository and you can control the branches. So or maybe if you are working in a separate aspect of that application, you can create a branches of that repository. But you can merge the repository to the original branches. What is branches and everything? I'll be coming to this thing later, maybe today's session or tomorrow's session. But just want to say, Git repository is the thing where we are storing our codes. Okay, it's a hub, it's a repository. So Git repo is a workplace which tracks and manages file within a folder. So it's working as a file structure or folder drive structure. Okay, we are pushing our files. Uh, the files are containing the code bases. Okay, and it's also tracks and manages those files inside those folders. But the repository creation, if this is a big project, there might be a dedicated team for Git. They will be tracking the thing from their side, but the developer should be only controlling the Git branches and all branches and code merges, this kind of stuffs, committing the stuffs, pulling the thing from the branches, whatever we have earlier committed. So those kind of stuffs can be covered, but there should be a dedicated team for Git repo creation and all. But over here, I'll be just giving you a basic introduction for everything. Okay, for a new project application, a new Git repository needs to be created. Yeah, this is the ideal scenario. Now some Git command. So this kind of command you can directly write in the Git bash. Open, I mean, whatever you have installed the Git in the Git, you just can open the Git bash over there and can put for a new repository creation from your side. You can just put Git init. Okay, so just I mean, this is the thing. Suppose you have installed Git in some work folder. So you just have to open this work folder. Suppose a directory, just you have to go through over there. You can check with the Git status whether that particular repository or that kind of folder is is having a Git repository over there or not. Okay, the Git status command will be helping us. Okay, let me show you this as an example. So I am this. I mean, I'm particular in this directory. Okay, so I can open Git bash into this folder structure, or maybe I can open the git bash. I can go to this command, I mean by putting cmd, I mean change directory cd, we can go to this path and we can check the git status whether any repository had been created into that path location. If not, then we can quickly type this command git init, then that particular till day 18 this should be a Git repository created over there. Some file should be installed over here, installed on, and that should be working as a Git over there. So it should be version. I mean, whatever file I'll be storing over here, it should be version controlled and it should be under Git. So this is the concept of actually Git, how Git is working. Okay. Okay. Now I want to share some graphical. Yeah. So this is the GUI, how GUI it's working. I think it's a source tree snapshot. So actually, maybe in a particular application, various teams are working or various people are working, maybe five, six people. Those are developer. So there is a main branch of that repository, and you can see we can create the branches in this way. Okay. Why it's branches? I'll be coming to the branches maybe tomorrow's session in the detailed manner. So just like from the main branches, they're creating branches because in main branches, some files and folder structure is there. They want to modify something on top of that one. Okay. And each of this point is called commit point. So something has been deployed in the main branch, just like this. Okay. In this particular branch, they have committed some code over here. In this sub point, they have also committed something. So from this commit point, some developer has taken this code version and they have worked something on top of some feature. So they have created this kind of commit in another branch. Okay. So when his or their code base is ready, they will be pushing back this thing again to the main. You can see over here, it's a new branch again. So Git has that capability. It will be checking. So you can see this main branch is also been committed. So when I'll be pushing this thing again over here, maybe this committing part should be missed. So that kind of thing we can check in tomorrow's session. There must be a conflict that I am changing something on top of that branch, a particular folder or particular file, and someone is also changed over there something. So if I'm going to push, whether it will be taking this commit change again in the main branch or it should be removing it, or what should be the thing. Maybe someone is pushing this thing and someone's commit is over here. So whether it should be correct or not, what should be there. I mean, there should be a conflict occurs definitely, but how to handle that kind of stuffs and all, I'll be covering that detailing part tomorrow's session. Okay, and this kind of description we can see. I mean, each of the commit, the developer should have to mention a comment so that the other developers, when he joined the company or maybe he's a beginner of the company, they can check from the description what is the topic that the particular developer had worked on. Okay. Some developers also mentioned um, I mean comment line and at the code side as well. I mean what are the particular changes? But that for that thing we need to open the code bases to check the command line code. But over here, while committing the stuffs, we can directly check from here only. Moving to the next slide. Okay. Today I just will cover this committing part. What is commit? So what I just mentioned that a developer should have to take the code bases from the earlier stored version, and he or she had to made the changes over there. So there is two steps actually. We cannot directly commit. Actually, the next yeah. So suppose you are working in a working directory. So I want to move my code, then I cannot directly commit. So first we have to add in, this is the git add option. We have to move the code into staging area first, then maybe multiple things we have pushed into staging area. So today I have worked in three or four sections, three or four changes over there. Excuse me. Three or four changes in my code bases. So I have pushed everything, every changes into my staging area. Then in a single git commit, I can push the thing into the main repository branch. Okay. This is the command for command line part. I mean git add or git add for adding the code in staging area, and git commit for committing the staged area thing to main repository. So the same thing I just mentioned over here. And while committing the stuffs, this kind of checkpoint will appear that someone has committed. So in this line, that should be easily visible. Okay. So yeah. And if you're just going, I mean, in graphical interface, there is option for adding the thing for staging and committing the thing as well. But in, if you are working from Git bash side, then this is the command git add and git commit. Okay. So I think there is nothing more for today for Git other chapter. So tomorrow's session will be covering, actually today it's a very small session. So just we have covered, high level of Git, what Git is doing and all. So tomorrow we'll be working on top of branches, the conflicts and all, and covering the rest of the portion for the Git. And maybe tomorrow is the last session. So from the beginning of the week, maybe the new session should be there, and we can see more of the insights on Git or any other stuffs for the AWS if we have the hands-on features over there. I mean, the ready-made environment or everything is there. I'll be contacting with the admin, and maybe that should be helpful as well. Okay, so that's all for today. We have learned Git and fewer components in AWS. Let's connect tomorrow's session for more detailed insights on top of Git. Okay, then. Thanks, everyone. Bye bye. Have a great day. Okay, I think Ashwita is there. If there is any doubt, oh, sorry.